All right, everyone, can you hear me?
Yeah.
Yeah.
Cool. So we're going to be going over Programming Foundations Part 2. Last week we talked about some variables, loops, talked about methods a little bit, I believe. Just some of the basic introduction stuff for Programming Foundations. And today we're going to be talking more about arrays, loops, methods. We're going to get into some object-oriented programming with classes, object instantiation, looping over an array, inheritance, and other object-oriented concepts. So to start out, let's talk about arrays. So when we were talking about variables last week, we could have a variable type string. Let's call this name1. We could set that equal to something. So I'm going to set that equal to Sam. And then I could do a console.writeLine. And I could print out that name1. And then we'll go ahead and do a console.readLine to keep our console open. When we run this, you can see that it prints out Sam. Now, if we want another name, that's easy enough. We can go ahead and create name2, set that equal to Tom, and we can print that out. Super simple, as expected. We get Sam and then Tom. Now that could keep going. We could keep adding more and more variables like this. Right? And then we could print each one out individually. Now, the problem here is, what if we're dealing with something where we don't know how many names we want, or say we know there's 1,000 names? Like, that's a lot of names, and that's a lot of variables to instantiate, and then to console.writeLine to print out each one of them. That is a lot of code there. So what helps us, we have a tool where if you have data that's similar, like you have a list of names, we can store those in something called an array. So we could do something like string names equals new array. Let's go ahead and call this one string names equals string array 5. Actually, I messed that up there. Create an array here. So we could put those all in here. Sam, Tom, we'll go Sally. We'll just go there. Sally. So there's an array. Or we could instantiate it like this, string names 2 equals new string array, right? This can be size 5. So there's two different ways you can make, there's multiple ways you can declare an array, but here's one way where you assign it all the values right there. So this is an array with 3 elements that are already assigned, and then this is an array that has 5 elements. None of them are assigned yet. So I could go ahead to assign them. I could say names2, because that's the name of this array. 0 equals, let's go here, equals Tom. And then you could set it equal to that. So I'm going to go ahead and delete this first one here. Now notice how I set names square brackets 0 equal to Tom. What that's saying is the 0 or the first. So arrays are 0 indexed. So even though this is an array of 5, it's going to have, and I'll change that to names now. It has 5 indexes, and those are from 0 to 4. So there's that one, 2, 3, 4. So those are all for indexes of this array. So the first element in the array, the first index, is always 0. That's really important to remember. So I can store a lot of similar data in an array. So I have an array of names, multiple names. So we could say Sam goes there. We've got Sally here. Let's say Samantha. And I'll give this the last one of Tim. So now we have an array that collectively has all these names. So they're not just separate variables, they're each an element inside of the array. Now that's nice, but the first thought might be, well, you still have to console write line each one of those if we wanted to print them out. And then we've actually just added an extra line of code. Because before with our variables, we could write 5 variables and then console.write line it out 5 times. That's 10 lines of code. Here we have to initialize an array and then assign 5 values to it. So that's 6 lines of code. And then we'd have to console.write line names 0, names, and all. We'd have to do it to all of them. So that's 11 lines at that point. The value that happens here with an array is we know we have a number of elements, and if we want to perform the same action for each element in an array, we can use a loop. So let's take a look at our for loop here. You have for, and then we'll say int I equals 0. So the first part of this loop is, there are 3 parts. The first part is declaring a variable. We're going to call it I. We're going to set it equal to 0, and that's going to keep track of where we're at in the loop. The second part is the condition that we repeat while it's true. So while I is less than names.length, so the length is 5. While I is less than names.length, so while I is less than 5, we're going to keep repeating. After each iteration, we want to increment I. So this I++ means it will go up 1 from where it's at. And then inside of here, we want to say console.writeLine. Now this is the part where we can't just say like name1, whereas is what we would write if it were a variable. We have to use the array. So it's names, and then we want to access one of these indexes. So we can use our square brackets and put the number that we want to access in there. So before we actually go on with this, I'm going to cut that for a second and show you how we would print one of these. So console.writeLine, if I want to print out Sally, I would print out names, square bracket, and 2. So this is the number 2 index, or the third index, because 0, 1, 2, it's the third index there. This, just like a variable name, refers to Sally. So let me go ahead and print that, run that, just so you guys can see that I'm not making up something. There we go. Sally printed out. So back to our loop. What would we put in here if we want to print out each one of these? Because if we put 2, let's see what happens if we put 0 first off. So if we print out for each one of these, this loop, we're going to print out 0, name 0. Let's see what happens. I got Tom
Tom
5 different times. And you can see that's because Tom is assigned to the names array in the 0th element. So basically this loops 5 times because that's the length here, names.length. It's going to loop. So what's happening is I equals 0. We're going to loop while I is less than 5 because 5 is names.length. So it prints out this, and then it goes back up here and it increments. So I is now 1. Is 1 less than 5? Yes. Prints out 0 again, the name 0, which is Tom, and it increments up to 2. It keeps going. So if we don't want that to happen, what we can do here is we can use I. Now I starts as 0, so the first time it will print out names, and this I will be 0, so it'll print out name 0, which is Tom. And then it increments and it checks, is I, which is now equal to 1 because it just incremented from 0 up to 1, is 1 less than 5? Yes, that's true. So we're going to go ahead and print out names, and I is now equal to 1. Names 1 is Sam. So it prints out Sam, and then it comes up here. It increments again. I is now equal to 2. Is 2 less than 5? Yes. So names 2 will print out Sally, and so forth. So let's run that. And you can see that it printed out all of the names. So that's what's very valuable about having an array and looping over it, because you could have 1,000 things. And so instead of writing 1,000 lines of code, you just write this loop here, and you're going to loop over each instance, each index, and you can print out the element there. So let's take a look at another option here. So this is a for loop. We use these when we know how many we want to loop over. We want to loop over the length. That is the value we're giving it. If we just wanted to print out I itself, you guys can see, not ni, just I. If we print out I, it's just 0, 1, 2, 3, 4. That's why we have to plug I into the array, so we can print out 0, 1, 2, 3, 4 index of the array. Now, another way to do something like that, which is a little easier, is a loop called a for each loop. So for each allows us to iterate over a collection or a list or an array and access each element by itself. So for each, we're going to say string name in names. What this syntax is saying is we are going to loop over each name in the names array. This is type string because the names array contains all strings. So instead of having to write console.writeLine names I, or the number of each one, we can actually just refer to name itself, which is defined right here. So what's going to happen is it's going to say for every name in my names array, now this could be anything, we could call this X. For each X in names, go ahead and print it out. So names is a list of string. We're going to call each string X as we're iterating over it. So in the first iteration, X represents the first string. In the second iteration, X represents the second string, and so forth. Now, like I said, you can call this anything, but X isn't really a good name because it doesn't tell us exactly what you're doing, and you want to write your code and name your variables in a way that it makes sense. Your variable names, your method names, your code should tell a story. You should be able to look at it and see exactly what's happening. I can look at this and say, oh, for each name in my names array, I'm going to print out that name. That's plain English, right? That's like saying, if you have a box of rocks and I say, for each rock, wash it or throw it over the fence or something, that's plain English. I can say for each of those rocks, throw them over the fence. And you would know, just take each rock and throw it over the fence. So make sure you're keeping that in mind when you name variables. So when you read this, again, I beating a dead horse, but I just like to repeat things. For each name in my names array, I'm going to print it out. So let's see if that works. So there's our first, these first 5 are from this loop, And you can see the second loop does the same thing. It's just kind of easier syntax, right? It's a lot less than all this.
So the for each loop is basically when you don't know the length.
So now let's say we had two arrays. Say we had another array called, let's call it, countries. Oh, and something to note about an array is an array has a fixed length. So once you set that length doesn't change. We'll talk later about some collections that do change, that you can add and shrink dynamically, but an array, it stays at what it's at. So I set this one to 3. That means it has 3 elements, no more. So let's go ahead and say countries 0. Set that to Canada. Countries 1, set equal to United States. And countries 2, set that equal to Mexico. You guys can see that my geography is very linear. Working from the north straight down to the south. We'll stick with the ones that I know the best. So now we want to go ahead and print out each one of the countries. So we'll do another for each loop. For each string country in countries. Console.writeLine country. Now, this block of code looks an awful lot like this block of code, right? It's doing the exact same thing. Let's go ahead and run it. You can see it prints out all the names, and then it prints out all the countries. The problem with that is we're repeating code. If you guys remember the dry principle, don't repeat yourself. Anytime you're writing code that looks super similar, you should think about extracting that and refactoring it into a way that it's reusable. So instead of writing all this, and granted that's not that bad, it's just a few lines there. What you should do is extract that into a method. So what I'll do here, let's see, we'll go ahead and create a method. We'll call it private static. Let's call it print items. And this method is going to, we went over this last lecture, the different parts of a method. So here's the name and here's the parameters in between the parentheses here. So the parameter is going to be a string array, and we'll call this array. And what is the method going to do? Well, it's going to be void, first of all. We need a return type. Void, it doesn't return anything. We'll move this code into there. And what we'll say is for each item in array, so we're making it generic now. We're saying whatever the array you give me is, for each item in that array, go ahead and print out the item. So now what I can do is instead of writing 2 different for each loops, I can just call print items, and I can pass in the array. Let's go ahead and print the names first just to make sure it works. So print items, names. Let's run that, and it works. So now it's 1 line of code, ignoring that we had to write this extra code because we can reuse it, as opposed to writing the entire loop. So then I can go ahead and I can write print items. I can pass in countries. Run that. There you go. You can see all the names in the countries. So we're talking about code reusability, and a loop helps us reuse some code because we can loop over and we can perform the same operation multiple times. A method allows us to take that functionality and build our own module, our own method. that says, hey, anytime I call this method, perform this set of actions on whatever I pass into it. Now, a method can have 0 parameters. It can have multiple parameters. Some things don't take parameters. Sometimes you might have a method that just says say hello, and all it does is prints out hello. So anytime you call say hello, it will print out hello. Now, this becomes real valuable if I have a whole bunch of arrays here, and I want to print out everything. I can call print items. I can pass in the first array. I can pass in the second array, right? Yeah. So that's methods, arrays. Let's move on to classes. Let's see here. Good. So classes. I'm going to go ahead to start with classes. I need to, well, before I create a class, let's talk about what a class is. A class is a blueprint. If you think about a house, if I give you a blueprint, you don't have a house. You just have the blueprint for the house. When you build the house, you might choose to use different type of siding or roofing. You could have different shingles. You could have tiles. You can implement it differently. But each house has a roof, and that roof has the set dimensions, but it could be a different, like I said, shingles or tiles. But the blueprint says what is on the house. It has walls, it has a roof, it has all this stuff. It has rooms. But if I give you a house, that is actually the object. That is the solid, real, tangible form of the blueprint. So our classes are going to be blueprints that say, hey, this is like the outline of what you're going to create from this blueprint. And then when the word's called instantiate, when we instantiate an instance of that class, then we have an object. So class is a blueprint, object is the tangible, real implementation of that blueprint, of that class. So I'm going to go ahead real quick, and we're going to add a new item. It's going to be a class. I will go ahead and call this class person. There we go. So here's my person class. We can start by assigning it some properties. If you're using Visual Studio, a shortcut is prop tab, and that will create a property and a getter and setter for it. So the first one, I'm going to go ahead and make this a string, and I'm going to call this first name. Then we'll go ahead, prop tab, string, last name, and we'll go int age. So these properties are they're the properties of the class. So each person is going to have a first name, a last name, and an age, and you can set that. And then there's getters and setters, which allows us to access those, which is nice. Then we can go ahead and let's create a method on here. Let's call it public void print age. And what print age will do, here's an example. I'm not using any parameters. Just like I said earlier, some methods don't need parameters. They do something without any input. So we'll say console.writeLine. Actually, let's call this describe person. Describe. We'll just call it describe. So describe, and we will say this dot first name, which is going to be the first name of the person, is blank. Let's say this dot age, this many plus years old. So there's our description. Just age and .toString. Oh, I don't have a plus there. That's the problem. Maybe I don't need the toString. There we go. So whatever the name is of this person, it's going to print that and then say is the age years old and put a period there. There we go. So that's great. So we have a model here for this class where those first name, last name, and age, and we have a method that you can call to describe it. We have getters and setters, and we'll actually go ahead and we'll use that now so you can see. So let's remove all of this, and we will go ahead and create an instance of our person. So to create an instance of a class, it's just like setting up a normal variable. The class becomes like a type. So we have string and int and bool and double and float. Now we just created person. It works just like another type. So if I were going to create string name equals and assign at a name, I follow the same pattern. So with that, let's say person, person1 equals new person. This new person, this is the syntax you use to instantiate an instance or an object from a class. So you use the keyword new, and then you use, this is called the default constructor, but it's just the name of the class followed by the parentheses. So that creates a new person. So right now, if I go ahead and I say, let's comment that out. If I say console .write line, and then I call person1 dot describe. Oh wait, no, sorry. I can't write line that. I just need to call person1 dot describe because it's void. It doesn't return a string. It just prints it out. If I call that, let's go ahead and run it. I get blank is 0 years old. That's because there's no name assigned to this person, and 0 is just the default for the int. So I got 0. But if I went ahead and said person1 dot, and look how my IntelliSense fills it out for me. I can say first name equals, let's set it equal to name, which is this variable. I'll go ahead and uncomment that. Name. And then I can set person1 dot age equal to 72. Then I can run it. And this describe method prints out Nick is 72 years old. Now that's great that you can do that. So now I have a person object that has first name and age. I could add last name, and it takes all that data and it combines it into one person, which is super useful. That is the core of object-oriented programming, is creating these classes that you can make objects from. But this is kind of like, if I want to add last name here too, let's add last name. If I can find the enter key on my keyboard. Person.last name equals Samson. So now in order to create this person, I'm writing 4 lines of code there. That's not really ideal to me. I want to be able to just say in one line, hey, the name is Nick, last name Samson, age is 72. So remember I called this a constructor, a default constructor? You can actually create your own constructors. And the constructor is what gets called when the object gets created from a class. So I could go ahead and say public. When you create a constructor, you use the same name, verbatim, case sensitive, so capital P, person, as the class. So I can say, well, in this constructor, I want to have the first name. I want to have the last name. And I want to have the age. Notice I did put the types for each, string, string, and int. So then I can go ahead and say, well, let's once you call this, whatever gets passed in, we'll set first name equal to first name. Notice how the first one is capitalized, second one is lowercase. The capitalized one is the class level, it's the class member. So in the lowercase one is the argument that gets passed into this parameter. So you're saying whatever gets passed into here, let's set that value to our first name here. Now another pattern you'll see a lot of times is they could be exactly the same. And when they're exactly the same, what you have to do, you can't say first name equals first name because it says assignment made to the same variable. So basically you're assigning whatever gets passed into itself. That's where you can say this dot first name. The keyword this here refers to the class, the inside of the class. So if I create person 1, this refers to person 1's internals. It's first name, last name, and age. So I can say this dot first name, that's up here, and the first name right here is the parameter. So this dot last name equals last name. This dot age equals age. So this constructor will allow us to create a person object from the person class and pass in the first name, last name, and age all in one line. So now, notice how this is underlined red now. That's because it says there's no argument given that corresponds to the required formal parameter, first name. You can see right here, I've got first name, last name, and age. It shows what we just put there. So it's saying, hey, you need to pass in something. So let's go ahead and pass in something. We're going to go ahead and call this person Tom Sawyer. We'll say he's 16. So now I've condensed all 4 of those lines into one line. I can run the app. There we go. Tom is 16 years old. So that way I can create a lot of different people now. Person 2, person, and I can pass in whatever I want there. I can pass in a string literal like this, or like you guys saw earlier, if I have a variable, string name, I can pass in the variable because the variable takes place of the string literal, the same. So there's name, and we can say Thompson 32. There we go, and I can call person2 dot describe. If I run that, you can see both people described. Now, this is the last thing I'm going to cover right now. But it looks like we're getting into the same pattern, just like when we had ints or strings, and we could create a lot of different ones of them, but they were still separate. And then we're running person.describe for each one of them. We'll say we have 100 of these. What is something we could do to keep them all collected and not have to write 100 different lines? We could use an array. So just like we had the array before, where it was string, array, or strings, whatever we wanted to call it. We called it names before, equals a new array of strings. Oops, just happened. There we go. New array of strings. We can do the same thing. We can say person, square bracket, so it's an array of persons. We'll call this people because that makes sense. Equals a new person array. Let's go ahead and say there's 2 for now because that's how many I have created. And we can go ahead and say people 0 is equal to, so instead of assigning that, we'll go ahead and paste it down here. Person 0 is equal to a new person, and person 1 will be equal to this person. People 1, sorry, will be equal to this new person. So now we have an array of type person. So what we can do, let's go ahead and modify this. Since these aren't strings anymore, let's go ahead and make this a person array. And we'll call this describe people. We'll say for each person, call it that person P. And we'll print out P there. But actually, we're not going to print it out anymore. We're going to change this, and we're going to call P dot describe. So for each person that gets passed into this array in this method, we're going to describe it. So now I can go ahead and say describe people, and I can pass in my people array, and that should call the method on each of these, so I don't have to write that line. Now, just so you guys know, real helpful hint, if you're wondering what everything is, if you ever double click on it, it will highlight the references to it. So I can see, oh, where's people? I click on it. Oh, people's right here. This is the people I'm talking about. It's an array of person. I'm passing that in down into here. Once it gets into here, it becomes array. I'm using it right here where it's highlighted now. So let's run that. And you can see that it describes both of them. So for today, that is as far as we're going to go. Does anyone have any questions?
Can you hear me? Hello?
Nope. Oh, wait, you know what? Wait. I had my computer
Can you hear us?
on mute. I can hear you now. Does anyone have any questions?
Yeah.
All right, what's the question?
So it seems like in this particular language, if you actually have a constructor with arguments, it makes the original constructor private. Is that true?
It does. It removes the default constructor. So if I wanted a default constructor, I could come back in here and I could add a default constructor just like that. So now if I go back, I can create a new one. So my person equals new. There's the default constructor. So that's called constructor overloading. You can have multiple constructors. So you could have a default constructor. You could have a constructor that takes, not JPublic, that takes just first name. And then you could go on and on. Obviously, you don't want too many constructors because that becomes bad practice. And there's other design patterns around that, such as a builder pattern, where you can have just a default constructor and then you can add things as you go. But yes, that was a good.
All right. So continuing on, if you do have let's see, the first constructor you created, you had 3 items in it, a string, and an int. Is there an error if I don't supply all that information? Such as if I go for a new person and I'm going to put 1 string in there, will that either cause an error or will it just fill in the first name?
So if I don't have this one and you only put in a string here and you don't put in the last 2,
right,
that will cause an error.
All right. Could I then use for that constructor, that same constructor, some sort of placeholder where I don't necessarily have to name it for now, but it will create the object? Is it like a quotation, or do I put null? Can I use something?
Yeah, you could do that. Oops. You could definitely go back through. So let me remove this again here. So if we have just that, and I come back in here, I have my error, you could do this. Put placeholders in.
Okay. Can I use null?
For a string, you should be able to. For an int, I don't know that you can. Yeah, you can't for the int, but for the string, you can.
Okay, so we're saying the int is actually a private. Is actually a simple type.
Primitive.
If, yeah. Primitive, that's what I meant, yes. So could we go to person and instead of using a primitive int, can I use like integer or something? Is there a type I can use that I can then use null?
Let's see. So I come from a Java background, which is very, very similar to C#. There is an object type of int. I don't know off the top of my head what it is, but yes, there is something you can use for that. I can Google it right now, actually. Let's go ahead. Let's see. C# integer wrapper. You can use a generic wrapper class for it. Maybe it's just capital ints. Let's try that. You know what? No, let me try one more thing here. I'm gonna have int. If we want it to be nullable, do that for us. Yeah, I might have to get back to you on that one. If you want to send me a Slack or an email, I can answer that question specifically. I do know there's a way in C#, not off the top of my head.
Okay. I don't want to hog the whole time. If you have a question, Gaston, just speak up.
The only thing I was trying to get my head around is that literally on this part, everything is revolving around an object and trying to make things as short as possible. Is that right?
Yes. In essence, it's not all about making it as short as possible. It's for code organization and reusability and practices that will make a code repository or your code easier to maintain and manage. So these practices will make it easier to manage, which has a lot of benefits to it.
So literally it's instead of having like a multiple for each loops, just contain it all in one little method and just call the method with that object from the specific class to get the specific things that you want, right? That's basically what we're doing here.
Exactly. Anytime you have a set of instructions that you need to use more than once, you should extract that and put it into a method. That way it's reusable and you can use it over and over again.
Okay, and then everything is working through the object, right? But is at any point can that object lose scope or focus?
Can that object lose scope or focus?
Like let's say you're working on the main, right? And you're working on all this, but then can that object that you're working with from that specific class lose scope of what you're trying to do? It can?
So if I try to refer to my person down here, let's call dot display or describe. It doesn't have focus. It is out of scope here. That scope is only within here. If I want to access it there, I would have to pass it in as a parameter, as an argument.
Okay. And is there a way to make an object be available anywhere for the whole program? Like let's say there's something that you need to be able to use anywhere, no matter what. Is it like a global thing?
So global variables are actually a real. They're not usually the best idea. If there's a way to avoid it, you should. If not, you can always put it in a class and have it static, and then you can access it globally, like math.py. That is a global constant that you can access anywhere. If you build a class and you can create it in static, and then you can access that anywhere.
Okay. So we don't do globals anymore.
No, you do. You can. It's not, if there's a way to avoid, like if you don't need it, don't use it. But there are times when you want to have static members that you can access other places. So yes, you can do that. What you would do is on a class that owns it, you would create a static. So let's say public static, just call it number for now. Public static int number, set that equal to 0 for now. Then you could access this anywhere by just saying person dot, not equals, dot number. Person dot number. Now I have access, well, I have to do something to it, so plus plus. Now I have access to this anywhere that I say person dot number.
Mm-hmm.
So static variable allows you to do that.
Oh, okay. So just make it static. Okay. Okay.
Cool. Well, I've got to get running. If you guys have any questions, send me an email or a Slack, and I will get back to you. And I look forward to meeting with you next time. Okay, guys, thanks for coming.
Awesome. Thank you.
Thank you.